Hey guys, today in part 2 of this series you'll learn the basics of Terraform. We'll provision a MinIO server to run as an LXC on Proxmox to be used as our foundation infrastructure. We'll then rely on the MinIO S3-compatible object store to track the state of a separate Terraform project, where we'll manage our main infrastructure. This will let us work from anywhere and update our infrastructure consistently as long as we have access to our Proxmox server. These skills are loosely transferable to cloud platforms like AWS, GCP or Azure, with the advantage that it costs zero to set up Proxmox at home, as long as you have some old hardware lying around. Let's jump right in. So today we'll start implementing our architecture that we designed on the previous video, and we'll focus primarily on the L1 on layer 1 for foundation, which is just setting up Proxmox, connecting it to Terraform and deploying a MinIO instance that we'll use for object storage. We'll also create a basic Terraform project for the platform layer, for layer 2, just to show that we can actually track this project's Terraform state using our MinIO instance. So for tooling, we are going to use Terraform, and to install Terraform I recommend that you use tfswitch. This makes the process of installation easier, but it also lets you change to another version of Terraform that is required by maybe an older project that you have lying around. You can just run tfswitch without any argument inside the project and it will install the required version. Then we'll use Terraform, and in here you have an example of a Terraform file, a main tf file, where we have everything on a single file. We will create our own structure here with multiple separate files, but this also works. There is no fixed structure. This example is for AWS, but we will be using a different provider. As you can see here, there is the AWS provider. This is installed using the required providers under the Terraform config. And we are going to use a different provider for Proxmox, and if you search Terraform registry you'll find several providers as well as modules that you can reuse. There is the Telmate provider and BPG provider. I prefer BPG because it gives you a bit more control and also seems to be a more active project than Telmate, and we can check that if we go into Telmate. It was published a month ago, but if we look into BPG you'll see that only 5 days ago there was a new version. They are very active. Now for documentation, you'll need to take special care with this Proxmox provider section and take a look at the authentication. You can pick API token, auth token or username and password. The one that I recommend that you use is API token. I'll show you how to set this up. And also we need the SSH access that you can also set up in here. Let me just search for it. So you can set up your SSH access as well. And we are going to set up ours using the private key, not the agent, because you don't have an agent always running. We'll also specify a username. So we'll do something like this. And whenever you see a file function in here, it means that this file is being read and added. The string is added as this variable over here, just out of curiosity. So for the foundation layer, we are not going to use Packer yet. We are going to simplify the process and just install everything using a provider. A provider is something like is a Terraform block, a general block that you can run. And we are going to use remote exec, which lets us run code on our LXC after we have deployed it. An LXC is just a Linux container. It's different from a Docker container, although Docker can use LXC to provision their containers. But this is the stateful container, so once you deploy it, you can log into the machine, change stuff, restart, and the state will be kept. Everything will be managed by Terraform on our side, just so that you understand what an LXC is. And what our process will be, we'll deploy a file which is a bash script with the installation instructions for MinIO. So we'll have a provisioner file. That file will get copied to our LXC, and then we'll have a remote exec provisioner that will call this installation script. Our secrets for this stage again will be managed purely by Terraform, and you should, after you extract the credentials from Terraform, and these will be randomly generated, you should store them elsewhere. This is not meant for long-term storage, okay? So if you lose them, you'll have to redeploy this stage, and you don't want to ever need to redeploy this stage because it will break everything else from that stage onward. So whenever you have a password, you should define the corresponding variable in Terraform. And again, I'll show you all of this next, examples of all of this stuff. You should set it to sensitive, so it will be redacted whenever it's printed. And we will do that if you set it as an output, it will also be redacted when you run output. So something like this, you would set output MinIO password, and the value is your randomly generated password. If you run Terraform outputs, they will show you there is in this case VPC ID or our MinIO password, but it will redact the value as a string called sensitive. But there is a way to access that, and I'll show you that as well. There are some pitfalls about this strategy. So it's not easy to redeploy MinIO, and we will keep a separate volume for our data directory where all the files, the objects will be stored. And it will not be easy to redeploy this as you do with Docker. There is a volume, there is a container, you just shut down container and redeploy. So there is an issue here. But we want our foundation layer to be as minimal as possible. That was the goal here. Maybe I will review this approach in the future, but for now, this is the idea. For this stage, this is how we're going to do it. We're going to keep it simple so you can learn about Terraform as well. If you wanted to transfer this knowledge to cloud platforms like AWS, GCP or Azure, then many of this stuff becomes irrelevant because, for instance, authentication is done separately via IAM, and there are easier ways to manage credentials using their own secrets and parameter stores and stuff like that. So now let's look at the Terraform project structure. Let's talk about that for a bit. So now let's talk about file structure, and Terraform doesn't have a fixed file structure, but it does operate per directory, and it can also have separate modules on their own directories with their own outputs that can be used by other resources. Although there isn't a fixed structure, there are conventions for file names and how to split everything across these files. So let's take a look at how our project looks. So there will be this new Infra directory within the Data Lab project. For now it's only on dev. It will be released after all the series is out, probably. So if we take a look at Infra, for now we've got our foundation layer files and our platform files. These are two separate Terraform projects. This needs to be so because we'll need the S3 from MinIO to be able to sync or store the Terraform state for the platform project. So as you can see, there are a few files here. There is main, which usually contains your main resources, all your main provisioning code. It's frequent that you can have other files like compute TF or storage TF, stuff like that. So you can extend from main like you do on other projects and create different files. Then we frequently have outputs as well, where we define our outputs. So let's say that we produce a password and we want to share it, or we deploy a VM to a fixed IP and want to share that IP. We can share that via outputs. They will be shown when you Terraform apply, and if it's a module, it will be the output of a module that you can access with the dot variable, dot output name. The providers file, so this file over here, the providers file will define all the providers that you are going to need for your project. If it's AWS, there will be for sure an AWS provider in there. In our case, we are using BPG Proxmox provider, and that's what we configure under providers. This means that we are going to configure the Proxmox host, username, all the credentials as well. And also for platform, we do that, and as we also configure the S3 backend for state storage, although configuration itself is elsewhere, but we'll get to that. As you can see, there is a scripts directory. This is just a utility file that we are going to copy to our LXC, as I said before. Then there is a Terraform TF-vars example. This is the committed version, but there is a TF-vars that is only local. Sometimes variables are committed, sometimes they aren't. It really depends. In this case, because it's a public project and you'll have your own infrastructure and I don't know where it will live, you will have to configure it yourself, so this is not committed. In the industry, it's frequent to have production configuration, development configuration in different TF-vars, and you can just call that config depending on what you are doing. Sometimes the dev config needs to be filled in by you. The production config is fixed for everybody, and these are committed within the repo. Under the variables file, we usually define our variables, so give it a string to describe it, the type of the variable, and whether it's sensitive or not, and some other settings that you can check on the documentation, but I use nothing else here. And under versions, we define our Terraform version, we define our providers versions and all our dependencies. Then for platform, we have a similar config, but we also have this state config over here. And we need that because we cannot use Terraform variables to terraform init with our S3 backend, because using variables requires init to be run, but init will require those variables, so there is a problem here. And the way they solve this is by adding the option to send a backend config, and that config is just defined as a regular TF-vars file. They call it config to distinguish from files within the project. But yeah, let's take a look at how these files actually look. So going into VS Code, we can take a look at our foundation layer over here. There are other files that are git ignored, like the state, which is a file that we are going to actually sync to S3 for our platform project, not this one. And so I would say that the first relevant file is versions. In here you'll have your Terraform block, where you have the required version for Terraform. This squiggly arrow means that it fixes everything up to the minor. And then we have our required providers. We are using BPG Proxmox, as you know. And also we have a few providers that are just standard, and you can not define these, but when you are linting a Terraform project, usually this will output some error. So I just add them by default to all my projects. Then we have our providers file, and in here we are configuring each of the dependencies that we defined under versions. So for Proxmox, we've got our endpoint, the URL, whether it's secure or not, And then we have our API token, which is built from the username, the token ID, and token secrets. And we have our SSH config, which is a separate config. And this provider will determine whether it can run the action that you define or provision the resource that you need through the API. If it can do that, it will do it. If not, it will SSH into Proxmox directly and run the commands that it needs to locally. So let's take a look at these variables. For instance, PM endpoint, PM insecure. These are defined on the variables file. And as you can see, there is a variable called PM endpoint, which is type string. And if you need to know what this variable is, there is a description. It's a Proxmox virtual environment endpoint URL. PM insecure is a boolean. It is by default it's false, but since we have no certificates running in here, we need to set it to true. Then the node is the name of the node running within your Proxmox instance, and we'll take a look at this in a minute. Our node is called DeLorean. And then we have the remaining configs. We also have a config for the host machine, a default path for your Proxmox key. Of course, you can change that if you already have a different key called Proxmox. And also we have our MinIO variables over here. Finally, we've got our outputs, and I'll go into mine in a second when we talk about how to provision everything, because this is the actual core of the Terraform project. And for outputs, we'll share the container password. So if you ever need to log into the LXC via Proxmox or via SSH, we can do so using this password. As you can see, output makes it mandatory to set sensitive to true when these variables are sensitive, as a precaution that we are not sharing anything that you wouldn't want to share. As you can see, these passwords are coming from the resource random password with this name, MinIO container, and we are accessing the result output from that module. And this is by default a sensitive variable, so it will be mandatory that we also use sensitive over here. So here we have our Proxmox instance. We've got a single node called DeLorean running on this instance, and I already have a backup set up for my NAS as well, but you would get these three by default once you install Proxmox. We want to manage users. We can do so by clicking on data center and permissions, and you can create users over here. There are two realms for these users. It can create a regular Linux user, PAM, or a Proxmox VE user. We are going to create a PAM user for Terraform, and this is useful because you all know, as you can see by the logs over here, when actions are ran by the automation or manually by yourself or somebody that logged into Proxmox directly. While you can create the users and the roles which set your permissions for the user if you assign it that role, you can do it via the UI as well as the API tokens. We are going to do it via the command line, just because otherwise we'll have to click each individual permission, and it's easier just to run the command. So if you go into your node and click on shell, you'll have access to this shell over here. You'll be able to run several commands. There are PV commands that you can call, PVE or PV commands, that will help you control the Proxmox virtual environment. And so first let's create a user with a disabled password called Terraform. This is a regular system user. Let's call it Terraform. And there we go. This means that we'll have our home Terraform over here. And also let's add this user to the Proxmox environment. So you've got this Proxmox virtual environment user management. and you can call user add Terraform, same name, and at the realm. So this should be our user. Now if you go into your data center and go into users, you'll find Terraform user over here. Now I'm going to paste this because it's quite a long command. We'll have to run pvum again, but we are going to role add, and we are going to create a role named Terraform, and these are the permissions that it will have, and this is the part that I really need to paste. These permissions are defined in the documentations as well. If you don't have enough permissions, you'll start getting 403 errors, and they are not particularly verbose. So it's better to just start from all open, because this is a lab. In the real world, you won't have this concern, just because you won't do it this way. You won't be managing Proxmox cluster in or likely you won't in a real world scenario. And so you can just copy it from the documentation as well, which is what I did here. Let's go back to Proxmox and let's run this. As you can see, if we go into our data center again and go into roles, there will now be a Terraform role in here, which is marked as not built in because we were the ones that created this role. Now we must add this role to our user. So you can do that by running pvum acl modify, and you give it a path. We use root, so all the paths will be manageable by this role for our Terraform user. And finally, let's create our API key, which we will need to be able to set up Terraform. We can do that by running user token add for this user at this spam realm. Well, let's call it data lab tech. This is our token ID, and let's pass it this flag priv-sep, which means that there will not be separate privileges. This means that our API token will have the same privileges as our Terraform role. Otherwise, it will have separate privileges, and this can clearly be useful in a real-world scenario. But right here, we are going to give it full permissions because Terraform will need to provision everything within Proxmox. So create this, and we have to make sure this is our token ID. We have to make sure that we save this value, because we'll need this to run on our Terraform next. So let me just copy this elsewhere. So now let's go back to our local machine and let's create our Proxmox key. I set this explicitly, although it's the key type is now the default rather than our RSA. I set this comment to Proxmox just so I don't leak my username and hostname, and we are going to create this key and drop it into Proxmox file. No password because this is for automation. And there we go, we have got the key. Now let's copy the public key. I've got this pb copy over here, although this is not Mac. I created this alias to xclip selection clipboard. You can do as well. I'm going to copy this, and now we are going to switch into Proxmox, and we are going to add this to the Terraform user. So we'll want to do create the SSH directory, and we'll want to vim to Terraform SSH authorized keys, and we are going to paste the key and save. And let's make sure that this file is owned by Terraform. Okay, and now we should be able to SSH from our local machine into Proxmox using this account. So let's test that out. Let's make sure this works. So I will want to use this key and log in to Terraform account, and as you can see, we were able to successfully sign in. Everything is working. So before moving forward out of Proxmox setup, because we are going to need to deploy Llama and we are going to need to use the GPU, we've got a 2060 running on this laptop where we are running Proxmox. So I'm going to show you the process to set up the NVIDIA drivers on your Proxmox machine. This is essentially just a Debian, but I'm going to guide you through it quickly, and we'll look at how to configure everything regarding the GPU for our VMs later when we pick up the Llama deployment. So first thing we need to do is to blacklist Nouveau. And in order to do that, you just v into the blacklist conf under etc mod probe, and you add blacklist Nouveau. This is already pre-configured for my hypervisor, so I'm not going to redo it. I'm just going to show it how I did it. Once you do that, you run update init ramfs -u and you reboot your Proxmox instance. Next, you make sure to update your packages with apt update and apt upgrade, and then you install PV headers and build essentials. Okay, and once you do that, you go into your into NVIDIA's website, and you select your drivers and you download them. This can change over time, but currently this is a laptop, so it's a notebook version, and mine is 2060, and we want to select Linux 64 bits probably. Okay, we just run find, and in here you'll find the latest drivers. You can click view, there is a download button. What I usually do is I just copy this link address, and then I go back into Proxmox and I just wget this script, and as you can see I already have this script, and then you can just run sh script and you'll be able to install the drivers. Then let's make sure that the drivers are loaded during boot by editing etc models load the models conf, and I just added NVIDIA mode set and NVIDIA UVM this, and then again we run update init ramfs -u and we reboot our Proxmox instance. Finally, I also recommend that you edit udev rules for NVIDIA, and I save it on this 70 file, and just drop this on your file so that you have permissions to run NVIDIA SMI, mode set and UVM. And once you do all this, you'll be able to run NVIDIA-SMI and get an output. And as you can see, let me just zoom out a bit. as you can see, my graphics card is now available within Proxmox. And of course we'll have to configure all of this for our VMs, but this is the hardest part perhaps to set this up. So going into our Terraform project, as I told you, I had saved the key over here. Let's go into Foundation, and you'll find this Terraform tfvars file, which serves as an example. You can pretty much leave this as is. In my case, I have a different node name, so I would change this to DeLorean, and I would also fill in the token secret over here with this value. Okay. Other than that, it's your option whether you want to change your MinIO admin user or change your default buckets, which I'll show you how I've set all this up in a minute. But that's it. As long as you copy this file to Terraform tfvars and change this key, make sure that the node matches your production version and that the endpoint also matches your IP. In my case, it would be this one. Okay. So I'm going to leave this as is because I already configured the project. Let's now close this. And now what you do is just run Terraform. I use this to run it from root, but you can just cd into it, and we're going to do that just to make it less verbose. So let's go into our foundation. You just run Terraform init without any arguments. This will pull any dependencies. Once you run this, you can run Terraform plan to check what it's going to do, and we'll go through the details in a minute. And then you just run Terraform apply. I use auto approve because I like to run a plan beforehand manually, and while I'm testing I don't want to write yes every time, so we do it like this. And this will hopefully connect to Proxmox and provision our VM. In this case it will be an Ubuntu 24.04 as the base image, and as you can see it's provisioning a file which is our installation script, and now this remote exec is running that installation script. This will download MinIO, it will download MC, which is the command that you use to control MinIO, and this will be used to create the buckets. Everything is within this script. Let's just wait for a second. And we're done. As you can see, the outputs are printed, but because these are passwords, they are printed as sensitive. But you can access these outputs with Terraform output. This will show you exactly the same thing. You can also do it like this, and with root, let's say we want our MinIO admin password. You can use this raw argument, and you have to give it a specific output, and this will print the password to the std out. I do recommend that you do something like this instead. Okay. And so now if we go into Proxmox, we'll see that this LXC has been magically created, called MinIO. We use a label because this is from the foundation layer. Everything from the foundation layer will be in the hundreds anyway. That's what we defined before. And if we go into console and we type root, I'm going to paste the password for the container. Oh, sorry, I actually copied the wrong credentials. So if we go into here, and we will want not the admin password, but rather the container password. Okay, I just copied it. If we go into here, and now paste the password, you are logged in. The way we deploy this MinIO instance was as a systemd service, so let's check if it's running. As you can see, it is running. If we go into the IP for the host for this machine, which I'm using the HCP, so it should be MinIO LAN or MinIO 9001 is the port where you get your console, your UI. As you can see, this is running. There is an admin password. Let me just quickly go back to the terminal and copy that password. Let's paste it. And here we are inside MinIO. And we have our buckets. We use this sandbox bucket just for simple testing. We use the lakehouse bucket, and you've seen this in previous videos, for our Duck Lake Parquet files. And in this series we are going to use this Terraform bucket to store the Terraform states for our other projects, our platform project and other projects that we might use or create in the future. Now let's take a look at the actual code. So going to VS Code, let's look at our main file finally. And this is how we deploy an LXC container. So we need this Proxmox virtual environment container resource. This is the name of the resource from our PPG Terraform provider. This is documented, and we give it a name which is called MinIO. So we can access this resource whenever we need it, like this. Okay, and so we just fill in everything that we want to set up. It's just regular configuration. Read the documentation, check what the options are, and you set them. You need to know a bit of Proxmox to do it, of course. So we use the variable to set a node name. We want the ID to be 101. Here is the foundation tag that you just saw in that pink color that is generated. The color is generated by Proxmox automatically, depending on the string. We want this LXC container to start on boot. It is an unprivileged container, so it doesn't have root access. And it supports nesting, although we don't really need nesting for this option. We could leave it off. This is just something that I had from a Docker deployment, an older Docker deployment. We're not going to deploy Docker in the future using an LXC. We are going to use a VM, which is better. But now we want 2 cores on this container. And let's quickly go back to Proxmox and check if this is the true. So yeah, we have 2 cores, we have 2 gigabytes of memory, we have a root disk with 20 gigs, and then we have an extra data disk that is slightly larger. It's 100 gigs. This is our main storage point. So as you can see, there are 2 gigs of memory allocated here. Our network interface is this virtual ETH0. Our disk is provisioned on our local LVM storage. It's 20 gigs. We also have an extra mount point provisioned on the same storage. This will be mounted under data. It will be 100 gigs and will be added to the backups. So if you have backup jobs, this will be covered. And then our operating system is based on a template for Ubuntu 24, and this is a separate resource. If you control click, you can go to the resource, which we define here. The resource is just a way for you to download this image using Terraform directly, and just to show it how this looks on the UI. Let's go in here. We go into, I believe it's local. You'll find CT container templates, and you'll find that this was downloaded. Okay. we go into our local LVM, you'll find our container volumes over here, our root and our data. And so let's keep going. We've got our initialization arguments. The hostname we picked is MinIO. We are using the HTTP for IPv4 only. Then we are using the public key that we defined in this resource if we need to access this VM. We don't actually output this key because we just use it internally over here. Let me show it how you can generate such a key. So you just need to use this TLS private key resource, which is available by default. We call it MinIO container and we use this algorithm as well. Then we also generate a random password, and as you can see, this is created using the random password resource. We give it the MinIO container name and we access this result output. If we go over here, our password will be 20 characters with no special characters. And then we set a connection over here that will be used by our provisioners. We don't use the agent, the SSH agent. We are going to log into the root user and we are going to use the private key produced by this resource. It's the same one you found during initialization, but we are using the public key over here, and in here this is the client in some way, so we are using the private key. And then the host will be the same as the one we set up on our initialization block under hostname. You should avoid, just hard coding it, because you can use this self to refer to configurations within the current block. And now we are going to provision two files. The first file, we are going to give it the content directly. And this will be an MVRC file with our environment variables. So the MinIO username and password will be sent here. We set the user using the variable as you saw before. So it's under our Terraform TF variables, as you can see. Not here, sorry. So this is MinIO user admin. Then our password was set by this random resource password. The MinIO data dir is the same as the mount point that we defined over here, so you can find it under path, and this is what we access in here, mount point 0 path, because we can have multiple mount points. And then we take our MinIO buckets variable, which is a list. There are some functions, some helper functions within Terraform that you can use, like join. We are just joining this with a space, so you can iterate it on a bash script afterward. This will be dropped into the LXC under root config MVRC. Then we copy our install MinIO file from our local directory scripts and drop it under root install MinIO sh. And finally, we use this remote exec to run that script. This script, we're going to go into it. This will source the config MVRC, so it will use the variables internally. And this is as you can see, it's sourcing those environment variables. You also set the user and group over here, hard coded, because it's the only thing that's running in here, so it's your option. And then you just have a bunch of regular command line instructions like you would do with a Docker file. And we update everything, we install wget and sudo, and then we download MinIO. They provide precompiled binaries, so this is a very easy way to install it. You just drop the MinIO server into user local bin, and we do the same for MC. Then we create the config directory for MinIO. We check whether there is a user with this name, and if not, we create the MinIO user, and then we change the group for the data dir and the etc MinIO to be MinIO, right? And finally, we drop these environment variables for the username and password into a .env file that will be used by our systemd service. As you can see, this file is the environment file over here, which will be passed to the MinIO server. And then we just run MinIO server for this data dir that is in the environment variable that we configured via the Terraform. So you could eventually change this within Terraform variables to be something else, although we don't expose it. We've got our mount point over here. We could expose this, so we would instead go into this path and use a variable for the path. Okay, just expose it. We fix our console address in the port 9001. We don't add this, we can access port 9000, which is the default, and we'll get redirected to a random port all the time. But if you save your tabs on your browser and you want to resume after having restarted MinIO, this would change, and this way it keeps it more stable. Then we do regular systemd daemon reload and enable. Enable will turn on this service on boot, and now we'll just start the service. And finally, we will set up an alias to using MC, so we can connect locally to our instance. And for each of the defined buckets, we just make bucket, right? MC make bucket. We create this local bucket, and that's it. That's how you set up MinIO using an LXC on Proxmox and define a very basic setup with Terraform. So now let's just do a bootstrapping for our platform project. So the structure is extremely similar. We still have our TF vars that we need to fill in, although we have no MinIO config because that's from our foundation project. And one thing that we need to add here is our state config. So for our state config, we have to define which bucket, and let me just turn on highlighting. So we need to config the bucket where we'll be dropping our state, and then the key or the path of your TF state file. This is actually the same as your local file. We are going to use a root directory called state for everything that is state related. Our project is called platform, and this is where the state will be kept. For our endpoints, we should point to MinIO on port 9000, which is the default. Our S3 will connect to this instance. For region, you should have something non-empty at least. I'm using EU OS1. The access key is admin, and in here you should paste your secret key. It's not access key, but rather secret key. This is a mistake. You should paste your secret key over here. This will be provided as the password for MinIO. So if you need to access it for some reason, this is how you get your secret key. Okay. And then you have to configure these options because MinIO is not AWS S3. If you were running this on S3, you wouldn't need this, and you wouldn't need this as well, and probably these would be available as environment variables as well, so you might not even need this or even the region. There is also a configuration called profile that you can use if you are actually using AWS instead. So once you do this, the way that you init this is you cd into Infra platform, and then you Terraform init with the backend config set to state.config. Okay, let's just press enter. because I had already tested this before and I destroyed the environment, there is a state that is available here, and I'm given the option to migrate this state, but I'm not going to do that. Instead, I'm going to just delete my current files. So this should be Terraform. Yeah, I think that's the one. So let's try it again. Okay. And we are done. Now we can just run Terraform apply. Let's run plan first. And as an example, I'm just producing some passwords so I can show you that state sync works. Okay. So I'm going to run apply auto approve. This should be instant. Okay. We can go back to our MinIO instance, and if we refresh, we'll see a state platform, and we got the state file over here. So it seems like it worked. And so now let's look at one of these passwords. So let's look at our Docker apps password, for instance. As you can see, it's QY0 something. Okay. And now let's just go into a terminal and let's clone. Let's go into TMP and let's clone our data lab project. And what we are going to do is just try to reconfigure this without any state and check if the password is correct. But we're going to do this twice. Once without any S3 sync, I'll disable it, and another time with the sync. Okay, because this is not affecting any remote infrastructure, it's just a local password for now. So let's go into Infra. First, let's check out dev, of course. Let's go into Infra platform. We are going to need to copy our vars and states so that we don't need to reconfigure this again. It's the same as the other project. And now, before we do anything, we are going to go into our providers file. No, sorry, we're going to go into our versions file. We are going to temporarily disable the S3 backend. Okay, this is the config that you needed to add, by the way. I don't think I showed you this. Those configs on the .config file would be added inside this block, but because we don't want to hard code any secrets into our project, we do that instead. Let's just disable this, and now let's Terraform init. And let's Terraform apply. And now let's look at our password. So as you can see, it doesn't match the password that is in the stored state. It starts with 8p. And if we go into this, you see it starts with QI. But we did disable the S3 state sync. Now let's just delete our Terraform state. Okay. And let's re-enable our backend, our S3 backend. And now let's Terraform init with our backend config set to state.config. Oh yeah, I guess I needed to delete our Terraform PF state as well. Okay. And now we are syncing the state with S3. Now if we Terraform output our password, as you can see, it's the same as the one that we have on VS Code on another directory. So we are running on -tmp over here, and on VS Code we are running on our main directory. We check password, you can see it's the same password. We can do something like apply with replace, and we can replace this password, so random password. Let me just check what the name of this output or this variable is. We are using the apps one, so this is the name of the resource that we want to replace. Okay, yes, I'm going to replace it, and now if I check it, it's okay something. Okay, if we go into our other project, you can check that it changed as well. And this is how you sync your state using an S3 bucket. This might be very, very helpful if you are working on a company with multiple DevOps that are working on the same infrastructure. Make sure you turn on lock. There is an option for locking when a Terraform apply is being run. Even if it's only one person, if you've got CI/CD that updates your infrastructure and you might be testing it manually as well, it's a good policy to enable locking. And yeah, that's it. Now that you've got a taste of Terraform and Proxmox, hopefully you are excited for the next steps, where we'll deploy the Docker VMs along with the GitLab VM. Make sure to subscribe and ring that notification bell if you don't want to miss that or the upcoming videos on deploying your own home lab data stack. If you're a data professional, this should be a sweet project for the weekend, or it might even support your activity if you're a freelancer. I'll keep adding these videos to the Data Library Infra playlist, but until then, make sure to read this week's blog post at datalabtechtv.com, follow the channel on Blue Sky for updates, and join Discord if you have any questions. Don't forget to drop a like and subscribe for all things data.